So you have seen how we can create a task and how we can delete a task, and I have also shown that we can use a function called vtask delay to give us a delay or waiting period. And I have also made a note of the function vtask delay that the input parameter is not in milliseconds. So the 1000 value that we have passed here is not going to be in milliseconds, but it still do give us a 1 second delay, and that is because our clock rate is 1000 hertz. So each period or each tick time is 1 over 1000, which is 1 millisecond, and 1000 tick means 1000 milliseconds, and that's going to be 1 second. But problem will occur if we change this clock rate from 1000 to, let's say, 5000. So right now my clock rate is 5000. So this 1000 will not give me a delay of 1000 or 1000 milliseconds. It will not give me a 1 second delay. Instead, it will give me a 200 milliseconds delay. So what I need to do if I want to keep this function independent of the value that I'm changing here is I need to multiply it with the clock rate. So this is going to be my clock rate, config tick rate underscore h hertz, okay, and divide by 1000. So if I do that, then it does not matter what milliseconds I want. I mean, if I want 500 milliseconds or if I want 200 milliseconds, it won't matter what exactly is the clock rate. So I can go ahead and I can change the clock rate from here, but the vtask delay will give me the delay that I defined right here. So let's say now I want 1000 milliseconds delay, and if I go ahead and if I run this, just take note that my frequency now is 5000, but before it was 1000. Okay, Bill's building. Okay, that's done. Here. Okay, there you can see it's printing hello world every 1 second. So that's how you use a vtask delay. Now there is another delay function in FreeRTOS, and that's called the vtask delay until. Now the difference between the vtask delay and vtask delay until is that vtask delay is not precise. It is not 100% accurate. Now what happens is, let me get rid of the screen here. Okay, when you're using a vtask delay and you're specifying the total ticks for which you want to suspend this task, then the CPU moves on to a different task, or it might move on to the scheduler, or it might be servicing some interrupt. You do not know, but by the time it comes back and starts continuing this task, then the time might be, it might go a few milliseconds over the time that you have specified. So if you have said, okay, I need a delay of 1000 milliseconds, so vtask delay will guarantee you that you will get at least 1000 milliseconds delay, but not exactly 1000. So it might go maybe 1050 milliseconds or 1100 milliseconds, we don't know. But vtask delay until will ensure that it waits for the exact number of ticks that you have specified, and the moment that period is over, it will come back and it will continue executing the next instruction. So I'm going to go ahead and I'm going to show you how that will work. So before I delete this vtask delays instruction, let me go ahead and let me write that function. So it's going to be vtask delay until, and there are two parameters here. The second parameter is going to be exactly this time duration. So just the thing that is the same input value that you use for vtask delay is going to be the same thing for 1 second delay. And for the input parameter, you need to create a variable that will take the current value, the last time where this task was unblocked. So I need to create that variable here, and I'm going to do that outside my infinite loop. So it's called tick time underscore t, and I'm going to call it my last unblock. Okay, and the value of my last unblock will be the exact time before executing this delay function. So that's going to be I'm going to use a function called xtask get tick count. So what this function will do is it will read the current value of the tick time, and then it will store it in my task, my last unblock variable that I've just created. So I'm going to pass on the address of this variable here in vtos delay until and semicolon. Now I can go ahead and I can delete this vtos delay here. Okay, just as a recap, so what I've done is I've created a variable of variable type tick type underscore t, and that variable's value will be it will get the current tick time from this function called xtos get tick count, and I'm going to use the function vtos delay until, where the first parameter is going to be the address to this variable that I've just created, and the second parameter is going to be the total number of ticks for which you want to have a delay for. Now this function, I mean, you really do not want to put it inside an infinite loop. It's not really necessary. So I mean, it will not make any difference, but you can actually take this out and put it outside the infinite loop. So we need to get this value only once, because what vtos delay function does is, after executing this function, it will automatically reload the value of my last unblock of this variable that we have passed in here, and this line of code will be executed again the next time, before at the end of this function. So basically, in short, this function will take care of reloading your variable value with the last tick time where the task was unblocked. So let's go ahead and let's run this program and see the delay that we get. Okay, so yeah, so you can see it's still printing hello world every 1 second. And again, as a recap, this function is going to give us an exact 1 second delay. So if you go ahead and try writing a few programs where you are printing the time difference, but try using a vtos delay and vtos delay until, and you will find out that this function will give you an exact 1000 milliseconds delay, because even if the CPU was servicing some other thread or servicing some other interrupt service routine, it will make sure that it comes back here after 1000 milliseconds and start executing the next instruction. So if I have something else here, let's say printing some other code right here, is going to do that after 1000 milliseconds that you have specified. But if this was a vtos delay, then it wouldn't bother coming back. I mean, maybe it would come back when it's time to service this task, and by the time it might go a little beyond 1000 milliseconds. So vtos delay is for precise delays, and vtos delay until is for precise delays, and vtos delay can be used for any general purpose delays, and just some simple delay that you want to introduce inside a loop. So that was about the delays in FreeRTOS.